Okay, welcome to Wednesday's class. Go ahead and get out your homework. I had a couple questions that were emailed to me about the homework. I think we got them all answered. All right, let's see. So we had the class exercises 2 through 10. So here we go. Number 2 is 5. Number 4 is 21. Number 6 is 28. Number 8 is 190. And number 10 is 10. And we had the problems 2 through 8 evens. So number 2 is 20. Number 4 is 35. Number 6 is 364. And number 8, big number, 319,600. 319,600. That's a lot of combinations. Okay, go ahead and answer question 1 on the Google Forms. All right, so here's the calendar. Just remember, this coming up Monday, we're not gonna have school that day. We're gonna call it a rest day. Gives us basically a week to go before the semester finals. That third week there, we'll do a semester final review on Monday and Tuesday, and then on Friday you will take your English final. The rest of the following week, remember it's a 3-day weekend because of Memorial Day. So Monday you have off. So Tuesday you'll come back and immediately take your science final. And then on Wednesday you will take your Latin final. On Thursday your math final. And then lastly on Friday you'll take your history final. Okay, so I just point that out because there will be a week between when we do the semester final review and when you actually take your semester final in math. So be cautious of that. Here's your homework tonight. As you're writing this down, today's a calculator day. I want you to have your calculators out. We're going to be converting fractions to percents. Just remember to convert a fraction to percent. Divide the numerator by the denominator, top by bottom, and then multiply by 100. In other words, move the decimal place 2 places to the right. Most people don't actually multiply by 100. They simply look at the decimal and just move the decimal place in their heads and then write down the answer. All right, so this entire chapter deals with probability, and we're going to jump right in. So when we did combinations and permutations, remember we're talking about possible things that occur. You know, how many different ways are there for something to occur? All right, what we've done so far, we've arranged items 2 different ways. Last night we did combinations. Remember, combinations is the arrangement of things when order does not matter. We had that formula NPR over RPR. And then the previous class we did permutations. This is when order does matter and the formula was NPR. Just remember there are typically far more far more permutations than there are combinations because when order matters, you get a lot of different more ways of doing that. But we're going to move on to some new stuff. Now, I don't know what your background was in previous classes and how much you've already done with probability. Some of you may have seen this before. Others of you, this might be a brand new thing. We're going to be doing something called probability. And probability calculates the likelihood or the chance of something occurring.
Forse sia cosa sarà 2 metri, 2 metri e mezzo, 2 metri 60, 70, non so. Dopo lo spianto di ieri, ci riprovo, questa volta dall'altra parte sto salendo, questo è un... Forse sia cosa sarà 2 metri, 2 metri e mezzo, 2 metri 60, 70, non so. Dopo lo spianto di ieri.
Wow. Okay, so what was that? Reason why I showed you that is that probability is something we deal with every day of our lives. We talk about what is the chance or the likelihood of something to occur. Scientists use probability all the time. Everyday adults and students use probability all the time. What's the likelihood that this will occur or that will occur? We're going to do an in-depth investigation throughout this chapter in this thing called probability. Now, just to word of caution or warning or something like, to you. Um, Obviously, whenever we talk about probability, we'll talk about playing games and games of chance. Now, obviously, I'm not teaching you how to gamble or anything like that, but I will say generally when probability is taught to you, we use games to illustrate probability. So just keep that in the back of your mind. No, I'm not teaching you how to gamble. Okay, so let's play a game. These are called games of chance. Games of chance are games where the outcome is not assured. You don't know what's going to happen. Okay, here's one example of a game of chance. You've probably seen these things before. There's an arrow, it's attached to a piece of metal onto a circular object. Typically there's numbers or colors, and the little arrow spins around. You flick it with your finger, it spins around, and then it stops somewhere. Okay, so this is going to be one of the games of chance. All the games that we will be playing, all the games of chance we will be playing are called fair games. So yes, obviously there's ways to cheat on things like this, but we're talking about a game where cheating is not allowed. The classic one is flipping a two-headed coin, right? Where the only thing you can get is when you flip the coin is heads. Also, when we flip the coin, it never lands on its edge. It's either heads or tails. These are called fair games. And more importantly, they're called fair games because each outcome, right, each possibility that can happen is equally likely. Like you're not more likely to get a heads or you're more likely to get a tail, right? You had a fair chance of getting either heads or tails. So that's what when we use the word fair game, we're talking about this. All right, so a couple definitions. Make sure you have these in front of you. They can be a little bit confusing when you first start doing this. The first thing we're going to talk about is what can happen if you can play the game. So for instance, this game is a spinner. If we spin, right, I mean, look at the game. We can get a color, right? We can also get a number. I know there's always a couple kids that will point out, well, what happens if you land between two numbers? Now, we're going to call this a fair game, so we're going to say that that's not a possibility. So all of those things that could occur are called in math world, those are called outcomes. So write that down, please. Outcomes. And that's what could happen or what can happen if you play the game. So if I play this game of spinning the spinner, I flick the arrow with my finger, it goes around, 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 eventually it stops on one of the numbers or one of the colors, right? Anything that could possibly happen. I could get a 1, or I could get a 6, or I could get a red, or I could get a purple, right? Those are called outcomes. All right, the next thing is that when you play the game, typically, you're looking for some specific outcome. Not all the outcomes, but one specific outcome. When we talk about one specific outcome, hey, I need to spin a 1, right? That is called an event. And the definition of event is one or more outcomes. For instance, let's say you're playing a game and you need to at least go 2 spaces, but anything past 2 spaces is good. Then the event would be spinning a number that is 2 or greater. So it could be a combination of events. Outcome is everything that could happen. Event is one specific of those outcomes or a combination of those outcomes. Does that make sense? Lastly, what we're doing in this chapter is we're calculating what is called probability. And probability is the mathematical likelihood of an event occurring, or the chance. So when we calculate probability, we are calculating a number that allows us to understand mathematically whether that particular event is likely to occur or unlikely to occur. So let's play a game. Now remember, we're playing a fair game. And once again, even though my arrow is literally pointed between 1 and 2, we're going to say that that can't happen. It's either going to land on a number or I should say, anytime that you spin the spinner, it will always land on a number. So it's going to be a fair game. And it's not weighted to one side. It's equally likely to land on a 1 as it is to land on a 5. Notice that would not be true if I made those pieces of the pie bigger than each other, right? If some were small and some were big, well, then that's not a fair game. You don't have the same amount of probability to land on a 1 as you would on a 5. But notice the space or the area of the purple region 1 and the blue region 5 are exactly the same. All right, now, as always in math, we have a way of writing things, right? A notation, and probability is no different from that. So there is a way to write probability. I'll show you an example. The P now doesn't stand for permutation. Now the P stands for probability. Then you have an open set of parentheses and a closing set of parentheses. And inside of that, you will write the event. In other words, what are you trying to do? Hey, I need to land on a 3. So that would be written P, open parentheses, 3. So that would be calculating the probability of landing on a 3. Okay? So for instance, if you were to read this, that's not P times 1, right? That's not the point P, right? That is the probability of landing on a 1. The probability of landing on a 1 or getting a 1. Okay? What does this one mean? That's right. The probability of landing on a 1 or a 7. And then obviously we can have words in there as well too, so this wouldn't be interpreted as the probability of landing on a yellow or getting a yellow. All right, so now notice I haven't shown you how to do that calculation. I'm just showing you how you write those probabilities. So it's P, and it's italicized, P, open parentheses, inside you write the event that you're looking to achieve, and then you close the parentheses, and then you do the calculation. Tonight for homework, when you look at the questions, you'll see the P, and then inside the parentheses will be the event that you will calculate. Okay, so I do need you to write this down one more time. Outcomes. Remember, outcomes is what can happen if you play the game. That's every single possibility. Every single possibility. And so this will be the formula for calculating each of those outcomes. Remember, there's lots of different outcomes. I could land on a 1, or I could land on an 8, or I could land on a blue piece of the pie, or I could land on an even number, that sort of thing. So we need to figure out how to calculate that likelihood. So here is the formula. In blue there is what you need to write down. So the probability of one of the outcomes, or one of the events that's in the outcome, the probability of that is written as a fraction. In the numerator, we put the number of favorable outcomes. There's lots of outcomes, right? There may be one favorable outcome. There may be more favorable outcome. In the denominator, you put everything that could possibly happen. And it's going to be a number, right? Everything that could possibly happen. So the top is called favorable, the numerator is called the favorable outcomes. That is, well, I like to refer to it as how to win the game, right? On the left side there it says P parentheses event. That's going to define what the game is. I want to land on for instance, a purple region, okay? The top number there, well, how many ways were there to be to win that? Well, there's 2 pieces of the pie that are purple. Well, that's how you would win that game. And the total outcomes, well, there's 8 numbers there, or 8 pieces of the pie there. So there's 8 total outcomes. Okay, a couple quick notes. Probability is, well, by definition, it's written as a fraction. But we know fractions can be written as decimals or percents. Today, we will be writing our answers as percents. But I do want you to remember is that when you convert a fraction to a percent, that middle step there is to convert it to a decimal. Therefore, probability is always between 0 and 1, right? It could be 0, right? If there's no way to win the game, then you have 0 probability, or it could even be a 1. I mean, what's the probability of getting a heads or a tail when you flip a coin? Well, that's the only thing that can happen, so it must happen. That'd be a probability of 1. Lastly, We will talk about odds later, not in this class, but in a future class. Odds are not probability. Odds are a different way of expressing the likelihood of an event occurring, but odds and probability are two different things. They do share some similarity, but don't confuse odds with probability. And since you don't know what odds are yet, don't worry about it. All right, today we'll be calculating probability. All right, some other quick notes. Just remember, if the probability when you calculate it is a 0, that means there's no way of winning that game. So for instance, if you're flipping a coin and I say, what's the probability of getting a red 2 when you flip the coin? You're like, well, there is no red 2, so therefore the probability is 0. Conversely, if the probability, what's the probability of getting a heads or a tail when you flip a coin? Well, those are the only two things that can happen. Therefore, the probability is 1. And you're like, well, where are you getting the 0 and the 1 from? I'm getting it from that fraction in the definition of probability. And we'll do a bunch of examples. Don't panic yet. Okay, I just want you to remember that a probability of 0 means it's not going to occur. No chance. But a probability of 1 means it must occur, right? You have to get a heads or a tail when you flip a coin. Remember, we're dealing with fair game, right? And we're not going to talk about any weird occurrences. Oh, well, a meteor could strike, and therefore the coin never hits the ground. We're not going to consider that as a possibility. All right, we're going to be playing, I think, 3 games today. And tonight for homework, there's like 3 different games that they talk about. First off, they're going to talk about drawing a card from a deck of cards. They're going to be talking about rolling a die, right? And the die will be 6-sided. They could also talk about rolling 2 6-sided dice, dice singular, dice plural. And then lastly, we'll talk about the spinner game itself. Occasionally, they also talk about a 4th game, and that's the one where there are maybe not cards, but tiles that go inside of a bag. It's basically a card game, right? All right, so I'll go through one example, or at least 1 or 2 examples of each one of these games. All right, so let's start with the spinner, right? So we know that the formula for calculating probability, the probability of a specific event is equal to the number of favorable outcomes over all of the outcomes. So for those of you that are still confused, let's fix that right now. All right, so step number 1 is you have to be told to calculate a specific probability. This is what you will be given. You'll be given, in this case, what's the probability of landing on a 1? Okay, now your job is to calculate that probability. Remember, it's a fraction, so you draw a fraction bar. Step number 1 is, well, figure out how many ways are there to win this game. How many different ways are there to land on a 1? And I don't mean, well, it could be in the middle of the 1 or a little bit to the left of the 1. If you're inside the area that's defined as 1, you've won the game, no pun intended, right? So therefore, there's only one way of getting a 1, right? There's only one 1 on this game. So there's one way of winning that game. If I land on a 1, I win, right? What else could happen? That's the bottom, right? What else can happen? Well, how many outcomes are there, right? Well, there's numbers. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 other things that can happen, including landing on a 1, right? By definition, probability is defined as how many favorable outcomes. That means how many ways to win the game over all the outcomes. Remember, there's 8 things that can happen when we play the game. Only one of them wins it. All right. Now we have a fraction. I said we're going to write our answers as percent. So we grab our calculator, 1 divided by 8, and then move the decimal place twice or multiply by 100, and we get 12.5%. So intuitively, as human beings, we can look at that number as a percent, because we understand that's a number out of 100, and interpret whether this is a good probability or not so good probability. So a 12.5%, roughly 13%, I'm rounding. 13%, you're probably not likely to always land on a 1, right? If it's only 13% probability. Let's do another one. What's the probability of landing on an even number? An even number. Once again, remember, all probability is written as a fraction. The top number is how many ways to win the game, or how many favorable outcomes are there. In other words, how many even numbers are there? 2, 4, 6, 8. There are 4 even numbers, so there's 4 ways of winning this game. If I land on an 8, I win. I land on a 7, I lose. I land on a 6, I win. There's 4. The bottom number, the denominator, is total outcomes. In other words, what can happen when we play the game? Once again, there's 8 different ways or different things that can happen when we play the game. I can land on a 1, 2, 3, 4, 5, 6, 7, or 8. All right, convert that to a percent. 4 divided by 8, move the decimal place twice. That's 50%. So the probability of getting an even number is, well, you're as likely to get it as you are unlikely to get it. It's 50%. Okay. All right, one more. What's the probability of getting a number that is greater than 2? Probability of getting a number that is greater than 2. So once again, it's a fraction. I need to count up the number of numbers that are greater than 2. So which numbers are greater than 2? 3, 4, 5, 6, 7, 8 are all greater than 2. Let's see, 3, 4, 5, 6, 7, 8. That is 6 numbers that are bigger than 8. Remember, the denominator is everything that can happen, all the outcomes. Well, there's 8 of those, so it's 6 out of 8, right? 6 divided by 8, move the decimal place twice, is 75%. So of those 3, which one is likely to occur? Well, you're more likely to get a number that's greater than 2 than to spin the spinner and get a 1. Getting a 1 was 12.5%. Getting a number that's greater than 2 was 75%. So you can see that you're more likely to get a number that's bigger than 2 than you are to land on a 1. That's not to say that you won't ever land on a 1. If I spin that spinner 1,000 times, I'm probably going to land on a 1, I don't know, about 12% of the time, 13% of the time. So that's starting to make sense? All right, maybe we need to do some more. All right, so let's see. For those of you who know what you're doing, go ahead and do this one. All right, so what's the probability of getting a purple number? Probability of getting a purple number. Okay, well, we need a fraction. Top number, let's see. The top number is how many ways to win the game. So how many purple numbers are there? All right, there are 2 purple numbers. So there's 2 ways of winning that game. I land on a 1 or an 8. The bottom number is always what can happen when we play the game. There's 8 different possibilities when we play the game. 2 divided by 8, right? Move the decimal place twice, 25%. You could also reduce that fraction to 1/4, 25%. Starting to make sense? Good. Now, what can be written inside the event thing can be written many different ways. Here's a different way of writing it. It says, what's the probability of not 6? We interpret that as, what's the probability of not getting a 6? What's the probability of not, these are the more challenging ones, probability of not getting a 6. All right, so what are you getting if you're not getting this? What wins the game? Well, let's just see. If I land on a 1, is that not a 6? Yeah, I won the game. Well, what if I land on a 2? Well, that's not a 6. I win the game. In fact, right, the only way to lose this game is to land on a 6, right? So there's 7 ways of not getting a 6. The probability of not getting a 6. There's 7 different ways. 1, 2, 3, 4, 5, 7, 8. We've done this enough that we know that there's 8 things that can happen. 7 divided by 8, move the decimal place twice. That's about 88% or 87.5%. Okay, that's you're likely not to get a 6. All right, last one. What's the probability of getting a 2 or a blue number? 2 or a blue number? 2 or a blue number? So let's see. A 2, well, there's only one 2. But there's 3 blue numbers. 1 plus 3 is 4, so there's 4 different ways of winning that game. I land on a 2, 4, 5, or 6, and I've won that game. Why? Because 4, 5, 6 are blue, and then 2 is 2. Right? There's 8 possibilities. That's 50%. Feeling confident? Yeah, the spinner game is pretty simple. All right, I said we're going to do 3 games today, so we just did the spinner game. Homework will be similar to that. I think there's more numbers. I'm looking at the homework right now. I believe there's 12 numbers on the spinner game they give you, but it's done exactly the same way. All right, so the next game is rolling dice. Okay, once again, I am not teaching you how to gamble here. We are using games to illustrate this concept of probability. All right, so we're going to roll one die. All right, eventually we'll get to 2, but we'll do 1 die first. All right, what's the probability of getting a 5? Well, when you roll 1 die, how many 5s are there on the die? Well, there's what? 1. But what can happen when you roll the die? Remember, the bottom number is the total outcome, everything that can happen. Well, let's see. I can get a 1, a 2, a 3, a 4, a 5, or a 6. There's six different things that can happen when we play the game. With the calculator, 1 divided by 6 times 100 is, it's repeating decimal, so I'll round there. So 16.7%. Okay? So likely to get a 1, or sorry, likely to get a 5? Well, it's not unlikely, right? It's roughly 17%. All right, here's another one. Probability of getting a number less than 5. Probability of getting a number less than 5. All right, so how do you win this game? You get a number that's smaller than 5. Well, how many numbers are smaller than 5 on a die? Well, there's a 1, a 2, a 3, or 4. So there's what? 4 numbers that are less than 5. Right? How many things can happen when you roll a die? There's 6 things. 4, 6 reduces to 2/3, 2 divided by 3, or 4 divided by 6. Once again, you're going to have to do some rounding here. So 66.7, so about 67%, yeah, you're likely to get a number that's smaller than 5, right? 67% chance of that occurring. All right, let's do one of those not ones again. So what's the probability of not getting an odd number? What's the probability of not getting an odd number? Right? Well, to win this game, the number can't be odd. It has to be, well, it has to be even. So let's count how many even numbers there are on one die. There's a 2, there's a 4, and there's a 6. So there's 3 numbers out of 6. Well, that's 50%. Some of you are feeling pretty confident. Okay, so let's change the game slightly. Instead of rolling 1 die, let's roll 2 dice, right? If you roll 2 dice, it changes things very dramatically. Okay, I'm going to show you something called a sample space. And a sample space is where we literally draw every possible thing that could occur. So notice here, if I roll a pair of dice, right, the first one could be a 1 and the second one could be a 1. Or the first one could be a 1 and the second one could be a 2. Or the first one could be a 1 and the second one could be a 3. And you go through every single possibility. There's the sample space for rolling a pair of dice. Okay. Notice there's only one way of getting a 2 and one way of getting a 12, because if the first one's 1 and the second one's 1, that's the only way of getting it. However, notice to roll a 3, well, there's a couple different ways of getting a 3. The first one could be a 2, the second one could be a 1, or the first one could be a 1 and the second one could be a 2. There's 2 different ways of getting a 3. So this one's usually pretty complicated, and typically you need to draw a sample space to get a good feel of what could occur. So here's an example. What's the probability of getting a 5? So we got to figure out the sum of the 2 added together has to be 5. So let's see. The first one could be a 1. How do we get a 5? Oh, the second one had to be a 4. There's one way. Or first one could be a 4 and the second one would be a 1. There's 2 ways. Any other way of getting a 5? Right? Well, yeah, the first one could be a 2 and the second one a 3. Or the first one a 3 and the second one a 2. Any other way of getting a 5? No, that's it. So there's what? 4 ways of getting a 5. Look at the die there and then figure out how many of those add up to 5. There's 4 of those in that picture that add up to 5. The 1 and the 4, or the 4 and the 1, and the 2 and the 3, or the 3 and the 2. Well, how many possibilities are there? There's 36 possibilities, right? So 4 out of 36, that's about 11 point, I had to do some rounding there. That's 11.1%. So it's not entirely unlikely to get a 5, but it's kind of hard to get a 5 with a pair of dice. How about getting an 8? How many different ways are there to get an 8? Well, let's see. How do you get an 8? Well, you can't get it if you roll a 1, right? Because there's no 7. But you could get it if the first one's a 2 and the second one is a 6. There's one way. Or the first one is a 6 and the second one is a 2. There's 2 ways. Any other way? Right? A 3 and a 5, or a 5 and a 3, and how about a 4 and a 4? And you're like, why isn't there 2 4s and 4s? Because remember, the first one's a 4 and the second one's a 4. That's the same way as saying the second one's a 4 and the first one's a 4. So that's why there's only one. If you look down the upper left all the way to lower right, there's only 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. All right, so we counted, 5 different ways of getting an 8, 2 and a 6, 6 and a 2, 3 and a 5, 5 and a 3, and 1, 4 and a 4. Okay, so there's 5 out of 36. Well, that didn't really get much larger than 11%. Notice that's about 14%. So once again, you're not likely to get an 8. I mean, there's lots of different things that can happen. You would think that getting an 8 would be easy. It's really not. How about this one? Getting a 7 or 11. 7 or 11. 7 or 11. Well, how many ways are there to get a 7? So let's see. 1 and 6, or 6 and 1. 2 or 5, or a 5 or a 2. 3 or a 4, or a 4 and a 3. There's your 7. How about 11? Well, let's see. 11 can only be, you can get that with a 5 and a 6, or a 6 and a 5. So I'm counting what? 8 different ways of getting a 7 or 11. So 8 out of 36. Hey, that's only 22%. 22%. 22.2% to be precise. So with a pair of dice to get a 7 or 11, it's a popular dice game. Yeah, it's not likely to get that either. All right. So tonight for homework, you're going to have some probabilities dealing with rolling a pair of die. Okay. I'm sorry. Tonight for homework, they're only going to have you roll 1. Now, for some reason, the book doesn't want to say the word die or dice, so they say game cube. That's just a die. All right, the last game is dealing with. Okay, so the last game involves cards, right? And for those of you that aren't familiar with them, we need to talk about some terminology they use with cards. So we're talking about a standard deck of 52 cards. Those 52 cards are made up of suits, face cards, number cards, and red and black cards. So for those who already know this, I apologize, but some need to be refreshed or introduced to this. So there are 4 suits. The suits are called clubs, spades, diamonds, and hearts. Face cards are the cards that have the hearts, the jack, queens, and kings, right? There are 4 suits, and there's 3 face cards per suit, so that gives us 12 face cards. The number cards, the numbers start with 2 and go all the way up to 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's not 10 of them. There's 9 of them, but there's 4 suits. 4 times 9, there's 36 number cards. Total cards, I said before, 52. It does include 2 aces. We don't consider ace to be face cards. And lastly, half of them are red and half of them are black. So 26 each of red and black. All right. So to do this calculation, we're not going to include jokers in the deck. What's the probability of getting a black card? So if you have the 52 cards in front of you and you draw one at random, what's the probability of getting a black card? Well, how many black cards are there, right? Some of you know this. Some of you had to refer to the previous slide. There's 26 black cards. There's 52 total cards. That's 50%. What's the probability of getting an even card? An even card. Well, let's see. What are the even cards? Well, there's a 2, 4, 6, 8, 10. There's 5 even cards. 5 even cards. But there's 4 suits. Right? 5 times 4 is 20, so there's 20 even cards out of 52. So about 39% chance. So yeah, you might get an even card. How about this? What's the probability of getting an ace, a 7, or a 10? Ace, 7, or 10? Ace, 7, or 10? Well, how many aces are there? There's 4. How many 7s? There's 4. How many 10s? There's 4. 4 plus 4 plus 4 is 12. So 12 out of 52, right? That's about 23%. Okay? Starting to make sense? Those are the 3 games. So rolling die, we have cards. Their cards, they're kind of weird. They call their cards A, B, C, and D, and they have numbers on them. They're cards. And then the spinning game. So those 3 games are what you have tonight for homework. Make sense? All right. Throughout this, if you look in the back of the book, they leave their answer all as fractions. I want you guys to write your answers as percents. Percents obviously give you a better feel for whether the probability is high or low. Sometimes just looking at a random fraction doesn't give you the sense. And remember, we're doing probability because we want to get a sense of whether it's likely to occur or not likely to occur. All right, so that'll do it for the class. Here's your homework. It's pretty quickly done tonight for homework. All right, so that'll conclude the class, and I'll see you guys on Friday.
Ci riprovo, questa volta dall'altra parte sto salendo, questo è